Hey everybody, so we're back today with some more OPSEC, number 2 in the series. And today we're going to be talking about disabling your webcam, your internal webcam, and your internal Wi-Fi adapter, and why you would want to do that. And this is going to lead us into some further conversations about kernel modules, about the initial RAM file system, and a few other things as we go through this. Okay, now I'm using a real laptop, streaming to my main machine, which is what you see here. So you're not going to see any notes, but I will post the link to the notes down there so you can reference back, all this stuff. Okay, so let's go ahead and get started. So webcam hardening, right? So a lot of people just put tape over their webcam, right? You see it, black electrical tape over the webcam, and that's fine, man, but good OPSEC is all about certainty. Okay, so disabling your webcam is stronger because malware can turn on your camera silently, okay, and you're like, well, it's got tape over it, and it's like, okay, great. So maybe they may not be able to get the image out, but there could still be sound, and then you could still exfiltrate the capture itself, right? And you got sound. Also, LED indicators can be bypassed in the software on some machines. And so the way to go about it is when you disable the kernel module that loads your webcam, removing that removes the entire camera driver from the kernel, right? So even if malware tried to access your camera, the device, it just doesn't exist. And so this hardware level stuff, guys, you can't spoof it, you can't bypass it, and malware, it can't do anything. All right, it's often said that software is obedience-based security and hardware is authority-based security. Okay, so how do you disable this thing properly, right? So first of all, what you need to do is you need to look for your video devices, right? Your webcam devices. So what you can do with that, you can do ls/dev/video, okay? Now you see here, I have two loaded up, okay? So how do you get rid of these? Well, you can actually remove, there's two approaches. You can remove these modules temporarily or permanently. But in both cases, they are very easy for you to re-enable if for some reason you need to. Okay, so to temporarily unload the kernel module responsible for handling USB webcams on Linux, you do sudo mod probe r UVC video. Okay, the UVC video, that is the USB video class driver. All right, so it's the piece of the kernel that knows how to talk to USB cameras. Okay, now when we run this command, you have to put in your password. Okay, oh, my passwords are so good, I can't even type them in right, man. All right, now when we go back and we try to list our drivers, they won't be there. Okay, they're gone. Okay, so the driver's been removed from the running kernel. The webcam has become undetectable to all applications, including malware, and Linux just acts like there was never any camera at all. Okay, now to bring this back, it's very simple, right? So you just we'll go back to our mod probe command, and we just remove R. Okay, and this reloads it. Okay, so now when we go and we look at our list, right, they're back. Okay, now, so that's fine. I even know some people that write scripts to run this when their machine loads. I don't get that. So what I do, the best thing to do is to permanently remove this. Okay, and to do this, you create a blacklist file in your mod probe D directory. Okay, which is basically where all your kernel modules reside. Okay, so to do that, what you do is you do echo blacklist UVC video. Okay, pipe that into sudo t etc modprobe.d, and then we just do blacklist webcam.conf. Okay, now so first off, for those of you that don't know, what is T, right? So what is this T? T takes input and writes it to both the standard out and a file at the same time. Obviously, right, so we got echo prints the text, the pipe sends it to T, and then T writes that text into the file and also prints it back to the terminal so we can see what's been written, right? Now, the reason I'm using T here is because the shell redirection operator, this one, right, it does not respect sudo. Okay, so if we attempted to use the redirection operator here, we would get a permission error, right? So that's why I'm using T here. Okay, so now with this in place, when you restart your machine and it comes back up, you will never get that again. Okay, your webcam is dead. And then what you do if you need to re-enable it, what you can do is after you restart your machine and you've gotten rid of it, what you can do is you can just remove the blacklist file. And then, right, so you just remove that, and then you reload the kernel module. Not used to this laptop keyboard. Right, and then, when we look, they'll be back. Okay, so, now, so what does removing a module mean inside the OS? Okay, so kernel modules are like plug-in components for device support, right? They're not just programs, they run in kernel space. Right, the most privileged layer. So when you run modprobe-r, the kernel stops the module, the driver disconnects the hardware, all camera devices disappear, right, under your dev video, and applications lose access instantly, and if malware tries to activate your camera, it's going to fail because the driver doesn't exist, right? So this is different from turning off the camera, right? Here, like, the OS literally no longer knows how to talk to the thing, right? It's gone. Now, why the big deal, right? So for OPSEC, right? So here, malware cannot bypass a missing driver, okay? Even highly privileged malware requires drivers to interact with hardware, right? So if the driver's gone, the camera's a brick, okay? This also will eliminate LED bypass attacks, okay? Because certain malware, obviously, right, can activate cameras without turning on the LED. And so this depends on manipulating the driver, but you got rid of the driver, so, right? And this also prevents programs from enumerating camera capabilities, right? So if dev video doesn't exist, programs can't probe that or fingerprint the hardware. And then you also get runtime control, right? You can re-enable the camera, whenever you want, explicitly, okay? So, let's talk about Wi-Fi hardening, all right? So, why would you want to do this? Why would you want to disable your internal Wi-Fi module, okay? So, internal Wi-Fi chips, man, they're black boxes, okay? Using external adapters gives you a level of control, all right? It's because internal chips, they may have firmware blobs you can't inspect. Most built-in laptop Wi-Fi cards use closed source firmware, and then that firmware runs inside the card itself, not in Linux, right? So that means you can't read it, you can't audit it, you can't verify what it's doing, you can't patch it yourself, you can't confirm whether it logs, stores, or broadcasts metadata. You don't know what the thing is doing, right? So these internal Wi-Fi chip firmwares, they often have capabilities that you can't control, right? Channel scanning, roaming between access points, background probe request, WPS behavior, um, regulatory bodies, right? They have to abide by the law. So so yeah, and so the threat model is not, is this card malicious, but whether, is the card predictable? Is this card under my control? And does anyone else, whether it's an attacker, the operating system, firmware, have influence over how it behaves? Okay. So using external Wi-Fi adapters is going to just make your OPSEC a lot better. Okay, because they give you capabilities that internal adapters often restrict or just outright disable, right? Because most external adapters, they fully respect MAC spoofing, they persist spoof MACs, they don't fight the network manager, and they don't reassign burned-in MACs during scanning, okay? Internal cards, very often, they randomize only during certain operations, right? And they leave the real MAC during power-up, right? Or scanning or roaming. They can resurface that permanent MAC whenever it wants to, all right? Because if you go in, right, and you do IP link set, to assign yourself a spoofed MAC address on internal cards, it may work, but it's going to be that burned in that permanent MAC could at any point kind of come back, right? But on external adapters, you can that spoofed MAC address you assign is always going to be there, right? So you want an external Wi-Fi adapter because internal cards, they run mystery firmware, they can leak metadata, and fight you, right, when you try to control MACs or capture packets. And external adapters are going to give you total control. You can spoof MACs reliably, and run monitor mode for analysis. You can isolate wireless identities, and you can physically remove the radio anytime you're done, right? You just unplug the thing. So the more removable hardware you rely on, the better your OPSEC is going to be, okay? So let's do that. Let's disable the internal Wi-Fi module. Now, before we do this, if you were to go in here and try to temporarily disable your Wi-Fi module like we did here with the webcam, you're going to run into in-use errors. You're just going to. Okay, this always comes down to a combination of three things. Okay, it's going to tell you the internal Wi-Fi interface is still up, the network manager is holding it, or another kernel module depends on IWL Wi-Fi, right? Which is the kernel module that controls your Wi-Fi adapter. All right, so I mean, you could go through and bring your interface down, stop the network manager. Remove dependent modules, ensure there's no process using the radio. It goes on and on and on. And it could all be in vain because it's important to remember, guys, your laptop, right, or your box, it could be part of the root file system stack, right? And so this is very common in laptops using internal Wi-Fi for early boot networking. Okay, we're going to talk about this a bit later. So if you see an error like mod probe fatal, module IWL Wi-Fi is in use, even after you stop your network manager, this typically means that the built-in driver is providing another module state, okay? And the module is being loaded too early in the boot path, okay? And we'll talk about it, but there's also the initial RAM file system. And that's what that's doing. We're going to talk about what that is, but what that's doing is that's preloading the module, right? So instead of going through all that, guys, you just need to permanently disable the thing, okay? And you do it basically the same way, right? You just do echo blacklist IWL Wi-Fi, and then you're going to pipe that in, just like we did before, to the same directory. So etc mod probe D, and then we're going to blacklist IWL Wi-Fi conf. Okay, right? Then, what you need to do is you need to do sudo update initial RAM file system with the U parameter. Okay, we'll talk about this command in a moment. It's going to do its thing. Yeah, there it goes. Okay, so now when you reboot and log back into your machine, you're not going to have an internet connection. Okay, your Wi-Fi driver is going to be gone. Okay, now, so what is this, right? So what is this initial, this sudo update init ram fs-u? What is that? Okay, so this tells Linux to update the existing initial RAM file system image and rebuild it using the latest kernel modules, configs, and blacklist, right? Which we did here, right? We created a blacklist, so we needed to update the initial RAM file system to target that blacklist so that it loads it. Okay, so during boot, Debian loads modules from the initial RAM file system before it loads the modules on disk, right? So if we change driver settings like blacklisting Wi-Fi or webcam modules, we need to rebuild that environment so that the changes apply before the full OS loads, which is what this command does. Now, when the system comes back up, like I said, that Wi-Fi is gone, right? It will never load again unless you want to remove the blacklist, right? So to do that, what you would do is you would do the same thing that we did with the webcam. So you would do, you would just remove etc modprobe d, and then we would just remove that. We would remove that, okay? But after you do that, you need to go back in and you need to update the initial RAM file system again, okay? Now, why didn't we rebuild the initial RAM file system when we removed the webcam module? Okay, so we didn't have to update the RAM file system for our webcam because UVC video is not early loaded in the boot process. Okay, so blacklisting it doesn't require a rebuild. Linux drivers fall into kind of two categories when we're talking about when they get loaded. So you have early boot or essential drivers, right? These are needed before the real root file system mounts, right? These are like Wi-Fi modules for network booting, storage drives, file system drivers, encryption. You know, if you have an encrypted hard drive, that has to load. GPU firmware for console output, things like that, things that your computer needs to start up, okay? And so these are often included in the initial RAM file system because the system needs them immediately at boot, all right? And if you want to blacklist or modify their behavior, you have to rebuild the initial RAM file system so the changes apply at boot. Then you have normal or late boot modules, okay? So these load after the file system has already booted enough to mount the file system, start UDEV, and bring up user space, okay? UVC video is one of these, right? Your webcam, sound card modules, some USB drivers, most peripheral drivers, right? So these modules aren't included in the initial RAM file system. They're loaded later by UDEV-D or auto-loading or something, right? And so these modules respect blacklist immediately without rebuilding. Okay? All right, guys. That's going to be it for today. We're almost at 20 minutes. Went by fast. So I hope you guys learned something. Disable that stuff. I'm actually going to have some recommendations. I'm not sponsored or anything, right? I'm going to give you guys some recommendations for external webcams and external Wi-Fi adapters that work well in the in Debian, that you don't have to fool around too much with to get working. So yeah, I'll provide some input for that, But yeah, so this is going to continue on. We're going to roll into the next OPSEC, and hope to see you guys there. Hope you got something out of this one. Ask those respectable questions, get respectable answers. And yeah, going to see you in the next one. All right, guys.